Okay, I'll see today regression in the supervised learning algorithm. As we discussed in the previous class, there is many classes we discussed it so far. There is a classification problems. So in a classification, also we consider some of the algorithms, support vector mission, naive Bayes algorithm, decision trees like that, and k nearest neighbor. So these are the four techniques we discussed. In the same supervised learning algorithm, another category is there is a regression. From today onwards, we'll discuss the regression, and maybe it will take 2 or 3 classes, and we'll close this regression. Once the regression is over, we'll move on to third unit. And after that, I will share this PPT as well. And those who want video link, somebody asked, I already uploaded in YouTube also. If you want, you can watch there in my name in YouTube. You just go to my name and then Balasubbareddy, Power Machine Learning and Applications. In that tag, it will be available. So as of now, I uploaded only first unit. In future, after completion of the second also, I will upload. And if you want, you can go through there also. And then regression is a process of finding the correlation between the dependent and independent variable, because some of the independent variables and some may be dependent variable, target may be dependent variable, like that. What we'll do in this case is it will it will find the process of correlation between, that means there is a relation between the dependent and independent variable. It helps to predicting the continuous variables, that is a market trends. So in the live trends and all, and then house prices. Maybe we can expect in that area what is the house price in the next year or something like that. Main task of the regression algorithm, find the mapping function to map the input variable and then output variable. Something like suppose y is equal to mx plus c. What is that? There is a relation between output, that is a target, and then input. So that mapping we have to define with respect to some of the constants also based on the given data. Suppose, for example, you can see here, now want to weather forecasting. We will use the regression algorithm. So to find the weather forecasting and all. So then weather prediction, the model is trained on the past data. For all the machine learning algorithms, I already discussed many number of times, we required as a labeled data in this case, especially for the supervised learning algorithm. We required the labeled data in the past data. And once the training is completed, then we can easily predict the future data. Suppose I want to know what is the weather condition tomorrow. Let us do that. So now we are to develop a model. Let it be as a machine learning model, means supervised learning algorithm. In that, if we want to use the regression, you are to train the model using the past data, past 2 years data or 5 years data, something like that. You train the model, then the model is trained, then you test that model. Once the model is ready, then we can enter the data, maybe tomorrow if I want to know. And if we ask what is the weather condition in the tomorrow, uh, then it will give you the target data. So like that, we need to do only the past data. I have to train the model. That's what they mean. Now we can see the types of regression algorithms. In the regression algorithm, again, there is a classified into different categories. One is simple linear regression, multiple linear regression, and polynomial regression. These are the one category of a linear regressions. In a linear regression, because in our case, we have two things mentioned in the syllabus. One is a linear regression, another one is a logistic regression. These are the things. So in a linear, again, we need to discuss simple linear regression, then multiple linear regression, then polynomial regression. So after this, we'll move on to the logistic regression. And other things already discussed in the classification, the support vector machines and all is applicable for the regression as well as the classification problem. Decision tree regression also there, and then random forest regression. So these are the some of the algorithm, but all we cannot be covered in one unit. That's why what we consider is the regression case. I mentioned in the syllabus linear regression as well as the logistic regression we used. And we can see the classification. What are the difference between classification and the regression? Because we already covered the classification problems in the previous classes. There is a support vector machine, then decision tree, KNN algorithm, naive Bayes algorithm, like that. We already covered some of the algorithms in the related to the classification. And now we are moving to regression. First, we will understand what is the major differences or comparison between classification algorithms and regression algorithm. In this, we can observe one by one. The output variable must be discrete in the case of classification. This is the case in the classification. But whereas in the regression case, output variable must be continuous. This is all continuous variable. There is a real number. Whereas there, it is a discrete one. In the case of classification is a discrete, regression is a continuous one. So main task of classification is to map input with the discrete output. Whereas here we can see input with the continuous variable in the output side. So we have to map, there is a input versus output in the continuous, whereas here is it is a discrete manner. So this algorithm are used with the discrete data, whereas here we can use as a continuous data. So you remember one thing, classification will always give the discrete thing. Continuous thing is a regression one. So regression problem will give the continuous data. And then the decision boundary, which can be divided in the data set into different classes. And here we find the best fitness line, which can predict the output more accurate. Best fitness line in the sense, suppose some data points are there, we have to give what are the best fitness line, which is covered more number of points, that will be as a best fitness line. This can be used to solve the classification problem, such as spam email. These examples we discussed, speech recognition, identification of cancer cells, etc. This is a classification problem. This is used to, regression problems such as weather prediction, house price prediction, all these things. So this can be divided into binary classification, multi-class classifier. But whereas here further divided into two things, linear and non-linear regression. So linear regression as well as the non-linear regression. Another points you can see, so both are supervised learning only. As you know that classification as well as the regression are related to the supervised learning only. But it is not the same, but it is comes under supervision only. But exactly classification and regression are not same. And the predictive task in the classification, when the target variable is discrete. So already many times I told, the classification is related to the discrete, and then regression is related to the, continuous is related to as a regression side. So like that, identification of sentiment analysis of piece of text. By using the text, we can able to analyze the sentiment, all these things. The prediction task in the regression case, this will be as a continuous. Example, suppose the salary of the person is given their educational degree and work experience, geographical location, and level of sensitivity. So all these things we can able to uh, discriminate classification problem as well as the regression problem. And then linear regression, we can see he tried to apply relations that will predict the outcome of an event based on the independent variable data points. So we try to apply the relation that will predict the outcome. That is only the difference here. We want to suppose we define this is the relation. Suppose what is the input, respectively what is your output. So it will be as a linear in nature. We can able to predict your output with respect to the input. So relation is usually as a straight line, obviously, and the different data points are close as possible. So in a straight line, the regression line, if I want to say, the data points must lie are very near to the regression line, this line. That means this is the optimal point, we can say that way. So this is the way we are to find output is of continuous form, the numerical values. So because it is a regression problem, it is already I said it is a continuous and also as a numerical value. For a output could be revenue or sales or number, something like that. Whereas in the classification, it may be class 0 or class 1 or true or false, yes or no, something like that. But whereas here, it will be as a number directly, numerical number. Independent variable can be single or a multiple. So as I mentioned in the different regression, linear regression, multiple regression, polynomial regression. So based on that, we can see that independent variable can be as a single independent variable and multi-independent variable. So linear regression algorithm represents the linear relation between the dependent variable. It is a y. Suppose the data is something like that. This is the y and this will be x and something are related by a, b, c. So y purely depend upon input variables. Let x is input. It may be input variable. Input variables going to be defined. The case. This means it value of the dependent changes according to the independent variable. This is what output depends upon the variable. Independent variables are the input variables are the features. And now relation, it just like a there, the dependent and dependent in straight line. Now y is equal to beta naught plus epsilon. So the is see there is a right line in y is equal to mx. So this I mean epsilon is let it be intercept and one linear regression is the variables you want you can change plus something that also is equal to I mean something like will be as a string of intersecting point then linear regression coefficient. Now you can see in the find least method, the method finding the linear example. You can see 5 weeks sales data in the given the linear regression to predict 7th and 12th weeks in the same. Understand this question. Give something up 5 E is a V. What they up to 7th and week sales. So what let it be here? A say you week after 5 weeks or 7th week, what is the of the sales you make? Or what is the sale? Or you can make it as a current thing. You can see the data in a weeks. They mention the data is something like that. First week 0.2 thousands and second week 1. Third week 2.6. There. Suppose the trend is like we good in week means sales means 7 and 12 weeks. That we can start to put the whatever independent variable and variable, and this is the variable. So is the dependent purely the x. It will be decided y in the each week. Now we can see points as per the now placing the the line that in general in that point or it is very near to the line. In that let it be as a y class to a naught plus 1x the relation or thing beta s beta x plus. So like this you can get your question. So now the question, what is your and predict? First if you get equation wherever it is there, here you can put it 7 line first. Well, you quick like this. Relation y is equal to 7x plus e. Least square method we are to solve the problem using this. In that the least you need these coefficients because unknown parameter is a not the x. Suppose they had 1 a1 x or y bar x bar that is xy bar into y bar divided by square minus. So this is the or the mean of the x given. I just take mean that will consider as a x bar. You need the final. We want what is and what is the value a. Now here there are 5 items. The I is there are the 5 items. In that, one to submit to get 15 by 5, 3. Like that, must find in that they're given like because in the required x bar into y bar like that. So to find x bar is the mean of like that. If it is the x level, we are to find x. I will get the x square. We are finding from we to find xi square because this will give and then x into n square the 2 then x into y. Now the bar is mean. So this is we get from given the data points, 2 data points we by finding sales we can you can direct substitute what they given values they mention one these 2 points your y is equal to a1 a naught into a1 that will you can see a1 is equal xy x bar into y bar and then x this is the all what is the so this is the for the table xy multiply xi and after that you take it as a mean it will be xy and now xy bar then x y bar x square. So now we can this is the this one is square bar. To notice here x square bar here x bar square. See, so you can substitute in what we have is x is a 3 because it is x bar square and already we calculated and then take that will be as substitute will get now a1 equation y is equal to plus a1 this right equation to get 0.5 and a 0.6 equal to get a1 regression equation. This is your formula y to a naught plus x. In you can able to get it a naught value can sub a1 value can sub then this is your regression line. So for the given data set run now the what is it here 0.4 into I mean plus point one Other time is like that. We can the prediction of the seventh week. We just multiply by 7. There is many thousands because they give in terms of the thousand. But whatever the variable is there, independent variable, we can able to we'll get it as a we like this. Once if you know your general regression line, in that you not an E1 here. That is, you can see in here blood pressure. So it's age, we can able that will be age is x-axis because it is a independent blood pressure axis. It is a dependent based on the age. Blood pressure will change. That manner we use this. Now we can able to draw the regression line. That again not to be x given as a so right this uh, this one as a just for regression line, and in that you can see y is equal to w naught w1x and all this fine. This also fine, but we should know what are the we can observe as w1 in that blood dependent variable age dependent variable blood age predict if any new age because in variable if new age easily find blood pressure. So this is what able to do the regression. We can see the line. We these line age blood pressure. We at any we can able to mark. Your you can see options are there. More numbers are near to that line. We call it as best regression line. If you draw one by one, see the distance of that is given more of that will be normal line. The so the trade distribution, there can be many lines to fit diagram drawn the that is the point. The prediction as the actual value to be so find the best fit line. Observe this line. Let it by as a origin. You draw a line, then y is because it is a is one in that case to x in that line. Now what we want to do if this uh, best fit or not, what we can find the is one point there in our data. The points is given, which is 56. Let 147 like that we will get the data from the data. This point near to this or not, we are finding the distance. Suppose y is equal to w naught x. Let point. Let w naught is 0 and w1 will happen is equal to x only. In this to x line, each point to the line. At each point, suppose in it be this is your first point. Consider not any problem. So now y1 minus let it be. So you can this error is giving as a 1. Sim y2 y hat. So this error is meaning in line is line on line. The error will be this is this is the point. The error is 1. More error. Just subtract that point is and this point is like this. We so means even to square and so on up to 6 given date and e plus e to 3 square got this. So like that you can use that error be treated as best fit. That is only the concept. So like that, suppose you can see everything like this. Omega and omega 1 and if I combine is something like this, just it's not a problem. What you can do that points you can check that. So earlier residual we got 14. Now what is happening? If we move line to bit shifted in the residual point. So and similarly, we adjust that line back. Regression is method. The only thing is there is we can able to find what is your now here see that is a and D is a y convenience for data week 1 1000 week 2 3 week 4 is 8000 like in that case we are able this is the transpose that means what for multiplication I say only that is the data 1 3 4 like this x we can see that the first car for setting this is only that reason bias is 1 this problem you can write and as usual 2 3 4 you write it as such y given 1 3 is the matrix we are going matrix the x matrix from the given data first column can setting up the bias case. So now what is the question is week. The reason 4 weeks what the next week today is your up to 4th week sales are there. Next week what we can expect pattern if you see it is like one thing it 1000 obviously. What is your exact you can linear regression. Yes, this is the A formula that is equal to having the X transpose into X inverse transpose up to so computation of this equation substitution what are the X you do and the result take it as X transpose and then resultant matrix to the Y. So in able to using matrix. First X we take a 1, 2, 1, 3 transpose it that this fashion 1, 1, 1, 3, 1. This is the X and into X then we get one because 2 rows to 4 columns that matrix 4 rows in 2 columns then resultant matrix is a 2 we get it as a 2 matrix by multiplying then come matrix it as a this portion taking you get it this suppose is already transfer and this in you here 1 3 that you can multiply then what is your finally is known to you and already we can see by computing finally we'll get it what you call 0.5 and is your so the value is nothing but a 0.5 because it is intersect A consists matrix. A is equal to in turn there is a naught another one 1. So you can write this equation value of this. What is this? Minus 1.5 minus 1. Is A1 X. So this final regression line. Regression line predict is your answer. 5th week, what directly in that you can substitute to 5th into variable 5th week, then 1.5 plus 2.2 will give 5. So that we can include whether your question is correct, your solution is correct or is weak. Then now we is it is more than this now is a 9 point something. Is only we are problem further. You are using matrix method. Simple method if they did in exam you can use matrix. It may be simple. See, is another I already linear regression. Linear regression. What then as a multiple linear in this model independent one whereas in the linear regression model one dependent independent variable that is a dependent variable then independent variable. But involves the predictions. So now if the regression, multiple regression or multiple dependent variable dependent. So why dependent variable multiple independent variables they are related to as a x to x something like this we call dependent variable. Y is a you can see dependent variable. So the dependent variable any number of independent variable. Now what will happen is going to be changed. You can see multi-regression model, the are independent variable. One is a this is what right? Now what will happen? Y comma x2. So many number of variables available. It is a independent x2, x3 give it as a independent variable is that you can write in similar to this one y is equal to a1x a2 2. This is what y is equal to a0 plus a1 a2 x2. This n is dependent variable or you can number x1 x2 x n. You can write it as dependent variable equation y is equal to linear regression y x1. This will consider up to independent variables is equal to y. So next are the predictor variables. The dependent the coefficient see the anything method algorithm that mathematical find a of this equation this way is a regression line that will be a multiple. Now we can see the full regression using matrix method. So again the formula that's all. Earlier we can and but now two input variable here I will be remains two input variable one output variable. So you can see two are the to and based on we can able to weekly sales be product product there is something maybe now we can search now matrix y and a you can consider y is your output x is your input. In that case dividing as to and so on. That is the reason as we discussed by asking the remaining as such data. This is 15384. Y. This is a 68. Now once if you know a matrix as per this, I suppose need to calculate a naught a1 then 8. In that case, this a naught fine for that previous formula we can write x into x inverse into x transpose give as a hat into a1 a naught that you can this equation get it as your y equation. There x1 x2 are unknown parameter. Asked any prediction. Suppose if x1 is equal to x2 is equal to 2 or 3, then what sales, weekly sales. Like that, we can easily predict. Now, inside portion, we are calculating first mathematical. Uh, the x transpose x multiplied the what is y here for this matrix 1 8 12. So in that, say what is your multiplication by it as a value, and after that again, after getting y, this is your value. That we'll get it as a maybe 3 by this is one value second. So this a naught is known, a1 is known to you. Once if you know all the put it here, we'll get is regression. That's what here, but we got a1, a. This is our equation. This we'll get it constructed model. You can see this is our regression. Minus 1 point something into something into any prediction. Now, once if we can easily predict prediction line, maybe they are asking x1 is this much, what is what we are expecting in this easily. For another is a polynomial. If the relation dependent and dependent, then of relationship between dependent and dependent variable not linear. Suppose answer something is then direct will fitting with that straight line. If not in a then they are linear regression not be used will be present. So this is what regression cannot be used. If it is what we call it as not in linear. So now what will happen? Non-linear into because not in linear nature, not go for as a linear regression. We'll go for as a regression. The data points are not in. So then we can see that one method transformation linear data, non-linear data. What will happen once you transform? We apply as a linear, then we'll get it as a result. Okay. And polynomial. This is what in this because we the first one is a simple, second one is a multiple regression, third polynomial. In the polynomial, we used only the raised points are not in that. You have to solve two methods. So non-linear to transform linear data to linear data. Then you can have regression. So using regression, that is one method. It's a transformation of linear data to the linear regressions. Linear regression. That is other way is using linear regression. This is the method. These two arises will data is not linear to go with if they require this linear regression from the nonlinear to convert, then apply that. Otherwise, we are directly using point regression. You can see that convert data to linear and example exponential is there a into x. This is our x, that is nothing but a non-linear. Then the relation can be done by function on both sides. So log equal to a into e power bx. And or logarithm you can apply. Then what will happen? Like that is equal to ln plus ln e, because it is multiple. So now if I this into multiplication x into now what that plus, so this will be linear. Once if you get that equal what is transformation, non-linear equation and equation. Any is not in linear. We are applying as a log and we are doing this. The function is a polynomial regression. This will be non-linear relationship among the way nth degree like this. So linear instead of forming one thing is you can apply, but second one you can go down. So the this can be directly used in a different level of curve linearity. Second degree called we call it quadratic transformation, and in that plus a to x square. And the third degree is we call q is a degree and also called as a male and so on and so forth. Male is the maximum degrees 4 are used polynomials. One straight shape, and there is a strange more. So that is the now we can polynomial problem and it leads over and hence to avoid this their maximum degree of 4 problem. Let's consider polynomial. Then what will happen? Y is not plus a square. This is the degree of polynomial. And we can add the changing x. We can able to third degree, fourth degree. Now, what is the x here? We are ordering this max n, then summation of xi square, and this will come back here, and then summation square and x cube will come here, so on. So this is matrix for polynomial y similar, right? And y is sum of y I 2 plus y, sum of x comma y and comma y. You need to put it into table fashion. Data is x and y put Y is related data 1, 4, 3, and so on. It will be, and now xi because whatever data you want from the coefficients a to a1 are formula x a is equal to x inverse. This is your formula. X value already. So just here it and some of this will get play this a and then a for whatever the I place as x and then some I also required all the sum of and then so this x and x y square. So this values you calculate here, put it in this fashion. You your now what is happening? Will be make of it. Apply. You can see here two things. One thing is putting that, other thing is mailing it. That is from this you can able to predict you want. You can put it in. You can regression is a regression matrix. So this is the you regression. What is the line we need to calculate? You can able to regression here. Regression above. What are the you need to calculate? Following matrix to evaluate linear regression. In that, you can see that error we need to calculate. Mean absolute. Another one is a mean error. Mean square. Then relative mean square. Coefficients of means. So this is a that is a coefficient of we need to. These are the matrices. Something to so in that case, we need to find out your performance. See in the next class. And otherwise you can hear. Yeah. Right. Anything to discuss, you can talk to me. 999.